Hey, hello and welcome to my SAT math class. My name is Josh Wiener and live here in New York City. On today's date is September 26th, 2023 at 7 p.m. And like I said, this class will be recorded for my YouTube channel and it will be offered free online by donation only, just as an order of business. This is to promote my class that I've been developing at tutoring houses in New York City for the last 10 years. And you see this Venmo link on the right. That's a photo of me down at Coney Island by the old cyclone. And that's the QR code for Venmo. So you can donate at Josh Wiener 10. The recommended donation is $50 per lesson. But of course, this is completely up to you and completely voluntary. But it does help me to continue to have time to work and develop this amazing course that has served for 10 years in tutoring houses in New York City. I've been tutoring in New York for well over 15 years. My students have received scholarships to high school, college, received college scholarships and acceptance letters, also graduate record exam. And welcome to the guests. Welcome to Aksata M, and welcome to this online free SAT math class. We're up to lesson number 3. And again, just to let you know, this is being recorded for my YouTube channel. So welcome tonight. The time is 7:02. And as I mentioned earlier, I'm going to give about 5 minutes grace time for any other students who would like to attend this class to come in. And also, these will all be recorded with the Google Forms for the class offered online. This course goes for $1,500 to $2,000 at real tutoring houses, but being a student who spent a lot of years working as a street performer and musician, I saved my money and went back to college. So I'm offering this as a free course just to give thanks to all the people who supported me as an artist and performer when I was younger in my 20s. So welcome, welcome. Arthur, it says Arthur.
Oh, yes, that's it.
Yeah, hi. So just
Hi.
3 more minutes and then we will begin the class. I'm just going to scroll
Okay.
through the carousel of slides just to make sure that it's active here on Google. And this is my math class that I wrote for tutoring houses here in New York City. Welcome.
Thank you.
All right, so I'll also cut and paste for attendees the links to the what we're going to be working with tonight before we get started. So give me just a moment. Here is the first link. Oh. And also link to the worksheet that we'll be working with Classwork. And the focus tonight is on linear equations.
Okay, so should I get started on the quiz that you sent in the
Oh, not yet. We're gonna get started in just a second. If you'd like, you can. It depends on your time budget as well. But this will
Okay.
be hosted as a traditional class lecture. So welcome to my SAT math class. And we're going to begin tonight with lesson number 3, linear equations. And just as a quick checklist for you, if you are you a student who's actually going to be taking an SAT exam soon?
I'm in ninth grade, so it's like a preparation.
Oh, good. So you're going to get ahead on your studies. I remember when I was growing up, I was lucky to have a mother who was a teacher and a dad who also taught law school. So my mom always gave me the lessons, a year or two ahead. And that really helped me get ahead in my studies. I went to the Bronx High School of Science and it helped me earn a scholarship in math. Yeah, especially with math, if you get ahead. So very good. Ninth grade, where do you go to high school?
I'm in California, so I go to Oak Park High School.
Oh, so it's earlier there. It's only about 4 p.m. You just got back from school or was
Yeah, I got back from school about 2 hours ago.
Oh, hey, all right.
Yeah,
So, well, welcome.
thank you.
Where is that, near San Francisco or LA, you said?
LA.
Near LA? Oh, okay. All right. How's the weather out there?
It's pretty nice, not too hot,
Okay, very good.
but yeah, it's a really nice weather.
Okay. All right.
Mhm.
All right. So remember that this is a standardized nationwide test. So for the SAT math class, you will have to review equations and word problems in algebra, geometry, coordinate plane, charts and graphs, probably in statistics charts, and a few other math topics from algebra 2. Now, the good news for ninth graders, or what, depending on your perspective on education, is that they're going to take off a lot of the algebra 2 on the new revised SAT. So it will be easier math. It will go from 58 questions to 44, and the math will be a little bit easier on the next SAT version that's coming out next year. What will be more difficult is then if you would like to be like, if you like computer science, if you like math like I did, I like computers when I was growing up, then you should take the like an AP class in computer science, or I would recommend AP statistics or AP calculus. As you get
Okay.
older, you know, taking AP classes is very, very impressive to college. And the thing that a lot of students don't know, if you're ninth or 10th grade, is that once you get to college, let's say you get like a 3, 4, or 5 on the exam, the college will give you 3 hours of credit, but over 3 out of every 4 student who passes their AP, they just take the same class over in college so that they can get used to the college environment and how it's a little
Okay.
different. So there's, unless you are on a really accelerated track and you have your own reasons, the majority of students, even if they take APs in high school, once they get to college, they're like, yeah, I'm going to be a math major. I'm going to go do this 4-year engineering program. Once they get to their first year of college, they take those same classes over, but in the college lecture format. Okay. So just relax if you're like, because you're a year ahead, but that's what colleges want. So when students are
Okay.
working and ready to go in whatever discipline you like. In education, we call it science, technology, engineering, or math, STEM. So if you'd like to be a STEM worker, it's the one of the most competitive fields globally, but it's one of the biggest growth fields, especially in not only the US, but the US is no longer the only country that has tech cities. Obviously, there are tech cities in China, which are, you see on the news. There are tech cities. There's no longer Silicon Valley. There's tech cities in India, right? And there are also tech cities in France and Germany as well. So if you'd like to know more about their programs, you can, of course, Google that online, like what good college programs are in these various tech cities. If you'd like to know more about that, I can guide you with a few schools. And I did attend Teachers College for math education. So I always have the latest data on what's going on internationally and what countries are most successful on the SAT. And unfortunately, the United States has been lagging. We're sort of in the middle of the top 100 countries now. All right, so what you should see on the screen, please confirm that you can see on the screen. You can type 1 in chat if you like. There's a 28 lesson class here, which is like a checklist for you on the skills you need for the SAT. So if you look through this checklist, you might say, oh, okay, if I'm getting ready for the SAT, here, let me get my annotator.
So the lessons on the screen is all the math topics I should know for the SAT?
Absolutely, it really is.
Okay.
So for example, there might be 2 or 3 questions on logarithms. Definitely at least 5 questions using the Pythagorean theorem, area and volume, and also you should be familiar with these types of charts and graphs. But of course, since 90% of the problems, more than 90% of the problems are one of these 28 lessons, you'll have a very good preparation and it'll help with your organization for this standardized test. The next thing to know, as I skip this slide here, is that, believe it or not, the math sections are arranged easy to hard level. So a strategy for any beginner is to try and get 10 out of 10 on the first 10 questions. Then know that 11 to 15 are the 5 hardest questions. Then if you skip to the grid-ins at the end of the section, you can do those first, check the time, because it's a timed exam, and then end with the challenge questions. You can also do this math strategy to get a higher score on standardized tests, do the first 20 in section 4, skip the challenge block, and go do any grid-ins that are easy for you, check the time, Let's say 30 minutes left out of 55. Then use the remaining 25 minutes on the challenge block. This also helps you manage your time, get a higher score because you're trying to get 20 out of 20 here. And then not wasting your time on the challenge blocks, making sure you're finishing this, and then go back and do that red block of questions. I've been doing this for 15 years for this particular standardized test. And what it means is that I've had more than 90% success rate with students being on the right half of the normal curve. And if you're going to take a standardized test like the SAT, which is no longer required in colleges, you want to get at least a 500 score. Colleges are not impressed if you cannot do the standardized test and be on the right half of the bell curve. That's just the sad fact. So if you take the SAT and you're like, oh man, I keep getting 400s, or English is my second language, I keep getting 400s in English, you don't have to include it in your college portfolio. Just note that, yeah, I'm the first of my family to go to college, or I speak multiple languages, or I work in a family business, or I take care of my brother and sister. Colleges know this. They'll just read it in your portfolio. So standardized test scores are really not as important as they used to be to colleges. But I do recommend, if you're going to go into engineering, that you get on the right half of any test, to the right of the mean, get higher than the mean on any test that you take if you're going into an engineering program.
So what's the highest score on the SAT that's possible? 800?
So 800 is the highest possible score. And the way they do that is, let's say this mountain of papers represents 2 million data points. Then they look at the mean value of all 2 million scores, and they call that one 500. And then they use something called the difference of squares, and they calculate the standard deviation, which is the 84th percentile, meaning that the students who scored 84 better than 84% of the students. And that's the gap for the standard deviation. That's given a 600. And then based on the variety of scores, they then calculate a 700 score and a perfect score of 800. So yes, the lowest score you can get is a 200, and a perfect score in math is an 800, and same as in ELA. Okay, so with the method of easy, mid, and challenge level, I mean, like I said, I've been doing this for 15 years. I've had a success of over 95% of my students, after taking 4 practice exams, were able to get a score of at least between 500 and 600 average. Right? And that's where you want to be. You want to use a course like this as your tool so that you can be like, oh, okay, I'm still bad at lessons, like I said before. Oh, I still need like lessons 15, 19, and 23 or whatever. Then you can focus on a few extra worksheets, budget your time so you don't stress so much about it. Have a guide that helps you target the lessons that are difficult for you. Tonight, we're going to go over linear equations, and you'll see the 3 forms that are always on the SAT in terms of testing. Before we do that, I'm going to give you a few shortcut tips on 3 examples for SAT algebra, which includes linear equations. Can you read question number 11 that's on the screen? Can you see the one that's up here?
Oh, yes.
Yeah. All right, so this question reads, it says, if 5x plus 6 equals 10, what do you think the value is of 10x plus 3? So can you give this one a try? Try and solve this one and solve what will be the value of the new expression based on what's given.
Okay.
All right, I'll give you a couple minutes. If you can type your answer in chat, then we'll go over.
Okay, I'll do that.
Yeah, all right, give it a try. This is just a warm-up.
Okay, yeah. I will.
All right, very good.
I got 11.
11 was correct. C11. All right, very good.
Thank you.
Can you explain how you solved that? Like, what did you do to solve that equation? What were your steps?
Okay, so first I wrote down the question as the given statement. Then I subtracted 6 from both sides, so I got 5x equals 4.
Mhm.
Then I just divided and I got x equals 4 over 5.
Very good. And then what do you do next?
Since x would be 4 over 5, I wrote down 10x plus 3 and substituted x for 4 over 5 and just multiplied 10 times 4 over 5. I got 8. So
Mhm.
then I added the 3 and got 11.
All right, very good. All right,
Thank you.
so once you solved it, and that was like less than a minute, you would earn the 10 points and go on to the next. They're about 10 points each on average. Then you go to the next question.
Okay.
Right. What I'm going to
So
do is I'm going to show you two quick shortcuts because
okay.
since it is a time test, it's good to know a couple of shortcuts on solving
Mhm.
these problems. And I'll show you what two other students said that are the most common shortcuts for these types of questions. All right, student number one noticed that 5x was in the equation, but the expression said 10x. So just like you said, they said 5x equals 4. But then what they did next was they said, oh, okay, I'll multiply by 2 to get a value of 10x. Then you know that 10x is 8,
Mhm.
and then just add 3 and done. Question, the correct answer was C, just like you said. But doing it this way, seeing that this element can be scaled times 2 if you can solve for this term and just double it,
Mhm.
saved about 15 to 20 seconds for student number one.
Mhm.
Student number two did something different. They saw the equation and saw 5x, 10x. So they said, okay, well, you know what I'll do? I'll double the whole equation. Then they wrote down 10x plus 12 on the left side, doubling the left side, and 10 times 2 is 20. When student
Mhm.
number did this, then they said, okay, well, now I have the right first term, 10x. That can stay, but I need to subtract 9 from both sides. Subtracting 9 from 12, get down to 3, and 20 minus 9 is 11. So
Mhm.
a different approach, but again, the same idea was changing the 5x to 10x in a math step. All right, so
Mhm.
these are two examples of common shortcuts for workers on problems like this. All right, any questions on the first example?
No.
Make sense? All right, I'm gonna give you another example of a good shortcut when you're doing SAT, and this you already know, I'm sure. We're gonna skip number 14 tonight, but question number 3, which is a word problem. All right, and it reads, I'll read it quickly. It says, the Borealis Lighting Company sells special bulbs that last for many years. However, each bulb costs $99 plus $8.25, 0.25% tax. What is the cost for 6 of these light bulbs? Rounded to the nearest dime. Well, as you know, you want to be as fast as accurate as possible. And if you look here, $99 is difficult to calculate. So why not round up to $100 per light bulb? Then the tax is just 8.25% on 100, which is $8.25. And then using your distribution skills, 6 times 108 is 648. And then another 6 quarters is another $1.50 for a grand total of 649.50. Since we rounded up, we know that answer B is too high. 649.50 is an overestimate. So that also eliminates C and D, and the student that used their estimation skills has finished the problem much quicker. The correct answer is A, by using estimation. Since the light bulbs are less than $100 each, it eliminates B, C, and D, which the writer of the SAT knows. So that student has used estimation, saved time, and has the correct answer A. All right. Any
Okay.
questions on that? Yeah, this is just the way SAT questions are written. These are both from old SAT exams.
Okay. I have no questions for this one.
All right. So you already know these skills from taking tests and doing math, even though you're only in 9th grade. But you're going to see it on this standardized test because it is the national standard. It is still the test for American students as they apply to college from high school. Excuse me. Tonight we are going to do a sample quiz, And like I said, I've been working at tutoring houses here in New York since graduating and being a teacher over 15 years. So I have hundreds of these questions, and I picked 2 easy level, 2 mid-level, and 1 challenge level for you to work on. So tonight, if you click on this Google link, which is also in the chat window, you can work on the 5 practice questions. So I always give the class 10 minutes at the school. So would you like to try tonight's quiz?
Sure.
All right, so click on the link and good luck to you. And can you tell me how to pronounce your name again so I can not
Athar.
it's Athar?
Yes.
All right, I'm Joshua. I'm Josh. All right, Athar,
Awesome.
good luck. I'm gonna mute so that you can work quietly. Please try
Okay.
tonight's quiz and I'll see you in 10 minutes, okay?
Okay.
All right, good
Thank
luck.
you.
See you in 10 minutes. Yeah. Hey, just 5 more minutes on tonight's quiz. 5 more minutes.
Okay, thank you.
Hey, just 30 more seconds. So please finish the problem that you're working on, and remember to use the bubble sheet on the bottom and to fill out the form email and name, and to click at the bottom of the form when finished with quiz number 3. 15 more seconds. That's time for SAT quiz number 3. If you can please make your final selections for the 4 multiple choice and the 1 grid in question. And the computer here says that you've submitted your response, and it says that you earned a 5 out of 5. Excellent. All right,
Okay.
very, very good.
Thank you.
All right, I'm impressed. All right. So all right, are there any questions that you'd like to go over with the 5 questions from specifically from the quiz tonight? Or did you have no completing the form?
I didn't have any big questions. The only question I had was number 1, which was the Mersenne primes. I've never heard about Mersenne primes, so I'm not 100% sure what it is.
Sure. So Mersenne was a French mathematician who contributed worked a lot with number theory. So you can see that he studied sets of numbers, and what I'll do is I'll write out the powers of 2 to the n. And he noticed that from his studies in math that a lot of primes, you take the powers of 2, which are 2, 4, 8, 16, 32, and 64, 128, etc., but stopping at 100, right? Because it has to be less than 100. So these are our candidate numbers. If you then do 2 to the n minus 1, often it's a prime number, he was saying in his studies. So 1, 3, 7, 15, 31, 63. Notice that not all of the numbers are prime. However, 3 is a prime, 7 is a prime, and 31 is a prime. As you know, you were able to solve 3 times 5 is 15, so that's composite. And 6 plus 3, that's also the digits add up to a multiple of 3. So that's also divisible by 3. 3 times 21. But in the search for large numbers of primes, if you were looking for a number that, let's say you're going to encrypt a message with the computer and you want a very, very large number, you're saying that, well, if you're looking for a prime and you want a prime number that's astronomically large, look at the set, for example, they follow along certain growth patterns. So he said there seemed to be a lot of primes on 2n minus 1 with the form 2n minus 1. So that was the French mathematician Mersenne.
Okay.
All right. Any questions on number 1? If you'd like to know more about prime numbers, there are different websites to help you find certain classifications of primes that are very close to certain mathematical formulas, right? All right. So if you did the count, though, the count was, and you got it correct, it was 3. All right. As is tradition in class, I'm going to go over question number 5 because that's the challenge level question. And if you just bear with me, I'll just do a step-by-step solution on how you too can solve it in less than 2 minutes.
All right, thank you.
So the way we do it is I'm going to draw a right triangle. And the way I'll do that, because it's a whiteboard, is I'll just draw a rectangle like so. All right. And then I can use the perimeter of this area and use the long diagonal to create my right triangle nicely. All right, so then it was given that the base is 3 and the height is h and the hypotenuse is 10 minus h. So the question was, what is the height of this right triangle, the value of h? So again, using yellow chalk, which I hope you can see on the screen, we're going to use the Pythagorean theorem for right triangles, using it as 3 squared plus h squared equals 10 minus h squared. So for the mathematics here, we're going to use a technique called FOIL, which a lot of ninth graders don't know. 9 plus h squared equals 10 minus h times 10 minus h, which means that 9 plus h squared equals, first we'll distribute the 10, 100 minus 10h. Then we'll distribute a second time with negative h.
Oh, this is the way I did it, so I know this method.
100 minus 20h plus h squared. And then notice that we have a common term on the left and right. We can subtract h squared from both sides. So I'll just eliminate it. We can also subtract 100 from both sides. So we have negative 91 equals negative 20h. And then dividing by 20, negative 20 that is, the computer should accept 91 upon 20. Or if you'd like to scale that, we could move each one up times 5, and we get 100. 9 times 5 is 450, plus distributing onto the ones column plus another 5. So then we get 4.55, rolling the decimal into to the left. Right. Any questions on those on those math steps?
No.
Okay.
I know that step that this when we distributed, so it was pretty familiar.
Excellent. So you knew FOIL technique. All right, very good. So you have a good teacher here. All right, very good. You have a good teacher in your school. In your school, that is. In you said Oak Park?
Oak Park High School.
Oak Park, yeah. All right. Tonight we're going to focus on linear equations. And does it the class you're currently taking Algebra 1, or are you taking geometry this year?
I'm in geometry.
All right, so you are a year ahead already. All right, very good.
Mm-hmm.
So the geometry lessons, if you stay with me, will begin at about lesson number 10. The first 10 lessons focus more on algebra, but we will focus especially on quadratics and on area and volume. This week on our focus on linear equations, I present to you the first page and just a simple example before we get to the classwork problems that I'll share with you tonight. So we always start with each checklist topic with a 2 to 4 page mini lesson just to get you focused on those specific lessons from your high school education. Tonight, we're focusing on linear equations. Linear equations are a fundamental equation for representing real-world situations that have a relationship defined with a fixed and variable term. In our math studies, we study direct variations of the form y equals k times x, which has the fixed point 0, 0. Linear equations expressed in slope-intercept form have an extra term plus or minus b attached to that equation, y equals kx. When graphed on the Cartesian coordinate plane, they always represent straight lines. Many SAT questions contain linear equations. So what you should know from Algebra 1 is that your teacher probably split the lessons into, hold on a second, slope-intercept form, y equals mx plus b. There will be questions with standard form, ax plus by equals a constant c. And also, given a floating point on the map, there's a point x1, y1 somewhere on the plane, we can represent it as, given the slope and a floating point, y minus y1 equals m times x minus x1. For the first example in slope-intercept form, the form is y equals mx plus b. We know the slope is 1/3 because it's in place for m. That's the rate of change, or rise over run. And then it crosses the y-axis, it intercepts at 6. So 0, 6 is a point that is part of the locus of points for the line. The same line can be represented in standard form. Here, we create an intercept chart. So we know from the 6 that 0, 6 is the y-intercept. To calculate the x-intercept from what was given above, we would have to set y equal to 0 then subtract 6 and multiply by -3. And we get that 18, 0 is the x-intercept.
Mhm.
Rewriting the equation, we get x plus 3y equals 18. So this is worth doing algebraically. So I'll do it quickly again on the left side with yellow chalk. In other words, if we have y equals -1/3 x plus 6, and we want to change it into standard form, the first thing I do is I'd multiply times -3 to get rid of the fraction, and we have -3y equals x minus 18. And then subtract x from both sides, and we get minus x minus 3y equals minus 18. Actually, in this case, since they're all negative, then multiply by -1. And that's also equivalent to x plus 3y equals 18. So just like in English class, where sometimes we're given a statement or paragraph, and the teacher says, that's good, but can you rewrite it so it communicates something else to your reader? Sometimes slope-intercept form is good, but what we need to know are the intercepts. So the teacher says, can you rewrite it into a standard form? And so that's how you do that. You do that using knowledge of Algebra 1. The other thing is that sometimes you're given the slope and a point that's part of the line. Here in the third example on the SAT is point slope form. And here we have the form is y minus y1 equals mx minus x1. A single point location on a line with a slope. For this line, there exists a point x1, y1 equals 3, 5, which is on a line with slope -1/3. So we want to represent that now using a point slope form. So hold on just a moment as I click away here. If I were to draw the a quick sketch, again without graph paper, we know that 3, 5 is definitely in quadrant 1 since both coordinates are positive. And I'll just space it out again using a rectangle that's about 3 there by 5 tall. And I'll place a star at the point 3, 5. But we want the rate of change to be -1/3. So that means that, and again, I'll just use red bricks. That means that y is going down 1 for every 3 units to the right. Down 1 and 3 units to the right. So here's the rate of change or slope as red bricks. You can also do that in reverse. So 3 to the left would be up 1. Then by connecting these corners, the upper left corner of each brick, that's the locus of points, which is the line. Again, you've done slope steps before, but instead of using a staircase, I'm using bricks instead, just because, which is the same thing. Okay, here you can see the point 0, 6, and 3, 5. But using the formula, since this corner point is 3, 5, plugging into the equation, y minus 5 equals the slope -1/3 times x minus 3. And there's a quick sketch of that line.
Mhm.
So with your knowledge of the first page, these are really almost all the problems that you will encounter with linear equations on the SAT. They'll either be in slope-intercept form, standard form, or point slope form. Or the instructor, whoever wrote the problem, will say, well, I'll give it to you in standard form. Can you change it into slope-intercept form? Or in one of these three, rotate it between one of these 3 forms, so it's more useful to me in my work. Right? That's really what the professor is doing when they give you a problem with linear equations on the SAT. So be familiar with these 3 forms as you get ready. And additionally, let's look at a quick word problem that's all linear. Can you read this one out loud? Because I've been talking for so long. Maria's problem with her cell phone, and
Sure.
it's common for the SAT.
Maria has a cell phone with a cost of only $3.25 per month. However, she has to pay 15 cents for each minute of use. The company then offers her $60 per month unlimited plan for all calls. How many minutes of use per month makes it more affordable for Maria to pay the unlimited plan?
Okay, so the first thing we have to do is you have to be fluent enough in English to translate into this equation for the cost. The
Mhm.
cost for minutes of times equals $3.25 per month. That's a fixed cost, as well as a per minute charge. Can you read the solution down below? What does it say next based on this equation here in the red box?
Since CT, which is cost and time, equals 3.25 plus 0.5. So since the unlimited plan is $60, set set the equation equal to $60.
Oh, okay. So this is plan B. So we're setting the unlimited plan. So plan B equals plan A, for example. A is when they're equal. All right, and then what happens next when you plug in?
Uh, when we plug in 60 for CT, then we would have to do the addition because there's no, or we would have to do subtraction as the second one, 60 minus 3.25. And then once we get our answer, which is 56.75, we would keep the point 15 on the same side, and then we would divide 56.75 by 0.15, which would isolate t, and we would get our answer from that.
Very good. So then we would have the exact time when the cell phone plan with the per minute use is equal to the unlimited plan. So then we can determine if Maria talks a lot with her friends on the phone, when it would be financially wise for her to go with the unlimited plan. So what was the number of minutes if Maria plans to talk on the phone a lot in the month? Can you read the box below? When is the unlimited plan a good plan for Maria?
Maria will save money if she chooses the unlimited plan. If she uses her phone, if she will use her phone for more than t is greater than 378 and 1/3 minutes each month.
Okay, good. Very good. So knowing that 60 minutes are in an hour, if she's like, well, that's like a little more than 6 hours, she's like, well, I'm going to be on the phone 20 hours a month, 20, if it's 30 days or maybe an hour a day even. It's like, well, if I'm going to be on the phone an hour a day and there's 30 days in a month, I should probably go with the unlimited plan, right? So she can plan accordingly. All right, very good. Okay. All right. So tonight, again, I'm sharing with you the SAT math course that's used in schools here in New York City. And I'd like to present to you proudly now the 25 question classwork. And usually because I'm only online for 90 minutes as I'm sharing the class, we're going to do a 20-minute practice. And you can do more than the even questions only, but that's tradition at the tutoring house to serve the students who are of varying ability levels and you can do as many questions as you want, but first focus only on the even questions only. The worksheet is designed just like the exam. So the first 10 questions are easy level, the next 5 are mid-level, the next 5 are challenge level, and then the review questions are the grid-ins. So what I'm going to do now is I'm going to leave the slide carousel just to show you the form here, which I shared in the chat window. So this is the classwork form. And you can see here the questions scroll down, and then the bubble sheet, just like with the quizzes on the bottom for you for the 25 questions. So I invite you now to take 20 minutes, and again, I'll mute, and work on the, wait, this is classwork 3, right? So that shouldn't say even. So that should say odd questions only. Oh, there it is. Why does it say even?
Okay.
Yes, it should be, it's an odd lesson, so let me fix that right now. Excuse me, a little typo. Odd questions only. So if you have more time in the 20 minutes, you can do as many questions as you like, but we're gonna cap it at 20 minutes so that we can review any problems the class wants to go over. Okay.
Okay.
All right. So click on the link, and if there's a problem, just type in chat if it's not working, and I'll send it to you again, or I can send it to your private email if you would like me to do so. Okay.
Okay.
All right. Good
So
luck.
if I finish all odd questions
You
by the
can
time.
Yeah, do as
Oh,
many as you like, as many or as few
okay.
as you like. You can skip around, but it is a range from easy to challenge level, just like the math section of the SAT. You got it.
Okay. Should I submit it after or should I keep it
Yeah,
open
you should
since
submit it,
I
Atharv.
did?
I'm just checking the bubble sheet off screen. So I have a split
Okay.
screen, right? So I'm just gonna check on my screen that it's aligned properly for you. Okay. All
Okay.
right, you got it. All right, so I'll see you in 20
Okay.
minutes. I'm gonna mute again. Again, just type in chat or give a shout out here in the Zoom room if I can assist you with setting up any of the equations. All right.
Okay. Thank
All
you.
right, good luck and go for it. All right, good luck. Thank you. See you in 20 minutes.
Oh, I have a question.
Yeah, what's up?
Uh, so for number 7,
Hmm.
it says a school decides to sell plush keychains of the school mascot for a fundraiser. If they buy 50 plush toys from the wholesale factory,
Hmm.
it costs $75. They sell the keychains for 335 each. How much profit will they make if they make 100 per sold?
Which,
So
which question number is this?
number 7.
7?
Oh,
Did you click on the classwork or the homework? Well, let me check.
I might be. I think I might be on the wrong one.
What is this?
Uh,
Back to the title. Which one are you doing?
uh, it says JW2542 SAT classwork number 3.
Really?
Mhm.
Does it say lesson number 3, linear equations?
Yes.
All right, can you go to the second page? Can you look at the heading on that page? Does it say SAT 3 linear equations? What does it say on the top on the banner?
Uh, it says SAT lesson number 2 classwork equation and word problems.
That's so weird. All right, can you click refresh on your form and see what happens? Click refresh.
Okay.
All right.
Oh no, it changed.
Did it change? All right, can you go back to the make sure all the questions say on the banner SAT lesson 3? Because I updated that a while ago. Because I just, I did them one at a time. So that was the lesson 2, yeah.
Oh, okay. Now they changed.
All right. Sorry. So can you start over? I'm so sorry.
It's fine.
That's weird that it didn't update. All right. Okay. All right. Yeah, I did that a while ago.
Okay. I'll continue now. Thank
Okay,
you.
very good. Yeah, because I think you were working on, yeah, those are the basic number sense word problems from
Mhm.
last week. Yeah.
Okay.
Okay, sorry about the confusion.
It's fine.
All right, you got it. All right, good luck.
Thank you.
Yeah, a little less than 10 minutes left on tonight's practice for SAT classwork on linear equations. Please refresh your form one more time before you bubble in. I also updated the bubble sheet. I didn't like I changed the choices to A, B, C, D, for example, and changed the font.
Okay.
All right, so if you refresh, it should say SAT classwork number 3, but the bubble sheet should be updated for you. And I checked the answer key, and we'll go over that in 10 minutes. All right, good
Okay.
luck.
Thank you. How much more time do we have?
Just 4 more minutes, then we'll go over 4 more minutes tonight.
Okay, can I get 2 minutes? I have to use the restroom real quick.
Yeah, sure, no problem, man. Yep.
Okay,
Yeah,
thank
very
you.
good. Yeah. Okay, so with the extra 2 minutes, that's time for tonight's practice on SAT classwork number 3. Atharv, are you back?
Yes, I'm back.
Yeah, hey. So please
Hi.
take a break from the problem that you're working on. Again, I'll leave the forms open to you, any student that wants to work with my online class. And you're free to use it at your leisure when you're able to study 24/7. But we need to stop for tonight for the online lecture and online share. What I'm going to do is I'm going to exit the carousel slide just to update it, just because I added a couple slides for you while you were working as well.
Okay.
And then go to the bottom of the form. And again, using the submit button, whatever problems you worked on will be graded for you by the school computer.
Okay.
All right, so go ahead and you've got the link. And what I'm going to do is put on the screen the actual solutions to tonight's practice. So here, if you worked on the odd numbered questions, question 1 was B, 3 was A, 5 was C, 7 was C, 9 was C, 11 was D, 13 was D, 15 was C, 17 was D, 19 was A, 21 was 58.6, 23 was 96, and 25 was 25 degrees. All right, I'm gonna go to the school computer in just a moment here. Where am I? All right, so it looks like you worked on a lot of the problems.
I got until question number 19.
Yeah, to question number 19. Oh, what's wrong with the Google form? Saying that they're different answers.
I'm not sure.
Oh wait, no. Oh, you did the odd questions only, right?
Oh yeah, I only did the odd, so that's
Why is it giving different answers? I'm gonna have to check the bubbles. What happened when oh, I hope it's not worksheet 2. Shoot. All right, here's what we're gonna do. So you did all of them up to number 17?
yes.
All right, let me just quickly go over the ones that were marked wrong for you. Looks like they're not aligned. So it said that you got sorry, I have to check. Yeah, it looks like 1, 3, 5, and 7 are correct. 9, 11, 13, 15. So I'll make sure that they're updated. Excuse me. Let's go over them together. Just to see if it's the bubbles from the other sheet. I can't believe that. Oh, I always check this beforehand. Sorry.
That's fine.
All right, so let's go to question number 9. Question 9 says, we'll solve them quickly and then we'll stop for tonight. Question 9 says, what point is on the path of the linear equation y minus 6 equals -3/4 x plus 3? And you put choice B, so I'm going to plug that into the equation. We have x equals -3, so -3/4 minus 3 plus 3 be on the right side, and if we plug in -6 minus 6, that would be -12, but this would be -3/4 times 0. So -12, 0. So that was B was incorrect. And it said the correct answer was C. Let's try the same thing. I'm just going to plug it in quickly. We have if we have -3 plus 3 on the right side. I think you see the okay is -3/4. So then we'll have 0 on the left and -3/4 times 0 on the right. So that's the kind of typical SAT balance here. Look that you get the same element in the factored form. So you can see right away that, oh yeah, 0 times whatever is still going to be 0. And C was actually correct. All right. So just be careful. Yeah, just be careful with sign errors. You had the right values, but B was the trick answer there, and C was correct.
Okay.
All right. Yeah, again, I'm second guessing myself because sometimes let's go to question number 11. Can you read question number 11 and tell me what you did? And we'll go over it together because I know you're in ninth grade and you have many years to get ready for this. And I'm not trying to discourage you or, or turn you around twice. I'm just saying that I did have a problem with the Google form as you saw earlier. All right, can you read number 11?
Sure.
Yeah.
What is the y-intercept of the line y plus 2 equals 3x plus 1?
All right, so it's in point slope form.
Mhm.
So we want to rewrite it so that it's y equals mx plus b. So can you distribute for me on the right side? What happens when you distribute for this for number 11?
Y plus 2 equals 3x plus 3.
Yeah, very good. All right. So now last step, so that's in slope intercept form, take away 2 from both sides. And then we get y equals, well, what's 1 take away 2?
Sorry, what was that?
What's 1 minus 2?
Oh, -1.
Yeah, you're working very good. You're working ahead of the class. Trust me, here you're in geometry class. -1 was the y-intercept. So for number 11, you should bubble in choice A.
Oh, I got what I did wrong. I put the slope. I misread that and put the slope as answer instead of the y-intercept.
Wait, for
So
number
I did.
11?
Yeah, for number 11, for the answer, I did the question correct, but I put the slope in as the answer by accident.
Oh, did you put C in?
Yeah, I misread the question and I thought we had to answer it as slope.
Sorry, there's a typo here. Let's fix this. Hold on. This should be 3x plus 3. 3 minus 2 is plus 1. So right, the correct answer was D.
D. Okay.
Right? Oh, if you put C, C was the slope. So you had a sign error there.
Yeah, no, I misread the question as I thought we had to put the slope as the answer, so I accidentally put 3 and I
Yeah.
didn't put the
Okay, so yeah, 3 was the slope. So if you put C3, that was incorrect for number 11. All right, let's go to the next one. Stay with me. You're doing very well. I'm not just saying that. Hold on, where am I? All right, let's go to question 13. Can you read question number 13?
A line in the XY plane passes through the origin and has a slope of 1/5. Which of the following points lies on the line?
All right, so we can use point slope form. Y minus y1 equals the slope times x minus x1. Given that, here's my given box on the right. The slope m is a fifth. And x1 is 0 and y1 is 0. So we get y minus 0 equals 1/5. X minus 0. And so y equals a fifth x. So it's the direct line starting at the origin and climbing up at a slope rate of 1/5. So we make a mini table and we do x and then y equals 1/5 x. We can plug in the x values and see if there's a match up above. So a fifth of 0 is 0, 0. So A is incorrect. So a fifth of 1 is 1/5 for the output. So B is incorrect. So a fifth of 5 is 1. So C is incorrect. But a fifth of 15 is indeed 3. So D was the correct answer for number 13.
Okay.
Right. And when I speak with you, you sound like you're very good with computers. So again, if you stay organized with the general form, I'm sure that you can continue with your success. I was like that too when I was growing up. I learned how to do basic programming, and it did help me a lot with the SAT if you like a computer class. Right.
Okay.
Any questions on number 13?
No.
All right.
I didn't know how to do it before, like before you explained it. Now I got it though.
Oh, okay. So yeah, start with the given information. And then this was the point slope form. All right, I need to listen better. Excuse me. Let's do question number 15. Can you read number 15?
Which of the following represents the relationship between H and C? Use the graph of the previous question, number 17.
Okay, so if we use the previous question, that was this one with the boat,
Mhm.
then we can see that. Can I do that? Hold on, let me X out so that we can put them together. So I'll move the graph so that it's together with this STEM question. All right, so we want to, using the graphing tool, let's focus on the graph.
Mhm.
And you see the y-intercept, like, you know how they say a boat is anchored at the dock? That starting anchor tells us like the location if we were to walk along the y-axis. What does it look like according to the scaling? What would be the y-intercept value for which I'm circling in pink, right?
5.
So which ones can we eliminate?
A and D.
Yeah, so we can definitely eliminate A and D. So I'm just going to put a red card over them, like so.
Mhm.
But then let's look at the slope rate. So you can use any two random points. But if I make a rectangle, say the boat is leaving the dock, so to speak, for a 5-hour tour, then you can see the point 520. Can you see that one, Athar?
Yes.
Yeah.
Yes.
All right, good. So I'm going to put this down for you. So this one is 0.5, and this one is 520. So now let's figure out the slope ratio based on the change in y over the change in x, right? All right, so here we go. So change is delta, and change
Yeah.
in x is 20 take away 5 for y, and 5 minus 0.
Mhm.
So then what's 20 minus 5? Athar, what's 20 minus 5?
15.
Yeah, so it's $15 for 5 hours, 5-hour tour. So then what's 15 divided by 5?
3.
And that's the per hour cost.
Mhm.
Okay, or slope rate. All
Mhm.
right, so it's 3. So B is incorrect, and the correct answer was
C.
choice C, like champion, right?
Mhm.
Okay, hold on just a second. All right. Any questions on number 15?
Nope.
Okay. Your voice, you sound like you're older than in 9th grade. So
Yeah.
working with 11th and 12th graders because it's the SAT. All right, can you
Mhm.
also read number 17, last one for tonight?
Sure. Bart bought. Sorry, what was that?
I'm sorry, I cut you off. Go ahead.
Oh, Bart bought a laptop computer at a store that gave a 25% discount of its original price. The total amount he paid to the cashier was P dollars, including a 6% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P?
Okay, this confused class and almost all the 11th and 12th graders as well. And only 1 or 2 students got it correct. The best way to organize it is we'll use capital P and lowercase p. So capital P for the original price, and then lowercase p for the lesser discount price.
Mhm.
Okay, so then P will get a 20% discount. So 100% of P, or the original price, minus 25% of the original price is the discounted price, little p. So I'm going to use the paragraph like that so you can see that it's a different P. That's the capital P. So I'm using like a post here with a double line.
Okay.
So the original price minus 25%. Well, what's 100 minus 25?
75.
Yes, I'm just left factoring the percentages,
Mhm.
and P can stand by itself. So 75% of the original price is the new price.
Mhm.
But that new price includes the total price they paid the cat was $P, including a 6% tax on the discounted price. Okay. So now we have to go to the discounted price. So then the discounted price plus 6% of the discounted price. So that's 100% plus 6%, or 1.06 times the discounted price, is the amount paid, which includes the 6%. So then, all right, paid.
Okay.
All right, so now I have to go back because this is the word, because of the wording. He paid $P. That's the amount he paid in the blue box. That was 6% of the discounted price. But the discounted price can be written as 1.06 times 0.75 times the original price. And that's the amount paid.
Mhm.
So if we want to get the original price, which was before of the computer, that means we want the original price. The original price was reduced by 75%. There's the variable there. We want to isolate for that variable. And unfortunately, I use P for the discount. So I'm going to change the letter. I have to do this now. We'll call this capital A and lowercase a.
Mhm.
This is capital A and this is lowercase a. And the reason I'm doing that is this is letter P, lowercase the amount paid.
Mhm.
And this is capital A, which is the original amount. So we want capital A by itself. So we have to divide by 1.06 and 0.75 on the left. We do the same thing on the right for lowercase p, which is the amount paid.
Mhm.
Sorry, I should have used a different letter. So this is A, capital A and lowercase a. Now dividing on the right side by 1.06 and 0.75, we'll cancel these factors. And we get the original amount is whatever what was paid divided by 0.75, 1.06 and 0.75. So that was the correct factor blocks
Okay.
from algebra 1. Those were the correct factors
Mhm.
based on the P dollars that were actually paid. Paid dollars, take the paid dollars, divide by the tax, 1.06, and the
Mhm.
discount, and you get back to the original price.
Okay.
That was number 17. I'll save this and I'll save this for you here. All right, last one for tonight. Thank you for studying with me. Was you did get up to number 19, you said, right?
19, or I think let me check my worksheet.
Yeah, so for number,
Uh,
yeah.
yeah, I got until number 19.
All right, can you read number 19 and I'll put up a graph for you just so that you can understand? Yeah, you got
Okay.
you got 4 out of 5 on the easy level ones, by the way. So easy level ones, you got 4 out of 5. So can you read number 19?
The graph of the linear function f has intercepts at a comma 0 and 0 comma b in the xy plane. If a plus b equals 0 and a does not equal b, which of the following is true about the slope of the graph f?
All right, let's look at the two cases and we'll use A is positive and if B is positive.
Mhm.
And the way we can do that is, I'll do this with you, Athar. Pick your favorite number between 1 and 5. Just pick a number between 1 and 5.
3.
Okay. So we're going to plug in 3 for A, or we're also going to look at what happens if we plug in 3 for B. So here we go. So you chose 3. So if A equals 3, then what does B have to be according to the formula? Then 3 plus B equals 0. So then what's B?
B has to be -3.
Yeah, it has to be the additive inverse, right? So then B is
Mhm.
-3. So now when we plot the points, A will be at 3, 0, and B will be -3, 0, -3.
Mhm.
So I'm going to quickly write the points down here for you here. This is A0 equals 3, 0. And this is 0B equals 0 minus 3.
Mhm.
If we connect the 2 points, is the slope of that line, is it positive, negative, or what's the
It's
slope of that concept?
positive.
It's positive because it's climbing up to the right on the screen where the
Mhm.
x-axis is positive, right? Because we have to order space some way, and it's tradition to make positive to the right and negative to the left. All right, now let's do the same thing, but we'll go with B equals 3.
So then A would have to be -3 then.
Yes, then A plus 3 equals 0. Now A is -3.
Mhm.
I'll plot this line in green for you, because now when we do A0, we'll go to -3, 0. And when we go to 0B, we'll be here. But lo and behold, we have A0 is now -3, 0. And 0B is 0, 3. And graphing the green line between those 2 points, is the slope positive or negative? Atharv, is the slope positive or negative?
Positive. Did
Yes.
my mic cut out?
Yeah, I didn't hear you. Sorry, I didn't hear you.
Oh, that's
Yeah,
fine. Sorry, my mic cut out.
so for both, if
Mhm.
A is positive, then we get a line like that pink line
Mhm.
in quadrant 4 with the anchor points in quadrant 4, because it'll be on the, let me explain. A will be attached to the, A will be positive, so it'll be attached to this axis, but B will be negative, so it'll be attached to this axis. But
Attached. Okay.
yeah, right, does that make sense?
Yeah, it makes
It is a
sense.
sliding point. If B is positive, then B must be attached to this positive y-axis, and A must be anchored at the negative. It must be here. These points can slide, but there'll be lines with slope 1. In either case, there'll be positive slope, so the correct answer is A.
Mhm. Positive. Okay.
Right, because they're additive inverses. You're going to get you're going to get a right triangle like that with an isosceles right triangle, right?
Mhm.
Because the distance, that'll be 3 along this axis, but -3,
3 along.
right? And if it was 5,
Oh.
it'd be 5 in this direction, but then 5 down in that direction, you get an isosceles right triangle in quadrant 4.
Mhm.
All right, so we're gonna stop for tonight, and
Okay.
sorry about the technical difficulties as
It's
we're
fine.
going
It's
through
fine.
this. But yeah, if you like, you can come on any Tuesday. Again, this is an open share
Mhm.
based on the course that I've been teaching here in New York City. And so
Mhm.
thank you so much for joining me tonight to study a little bit of math.
Thank you.
And if you'd like to learn more about me, I have a master's from Columbia University. You can go to the
Nice.
Wix website, and there's teacher parent praise and stuff, and other sample lessons. If you'd like me to be
Mhm.
your online tutor, just leave me a message or send them to my email. And if you would
Okay.
like to, it's totally voluntary. You can donate from $1 to $100, anything that you think the course, if it's useful to you. And maybe I'll see you next week on October 3rd if you'd like to study more for the SAT.
Okay.
All right.
Great.
So
Thank you.
thanks for joining me. And thanks to your folks, and good night. Happy studying.
Thank you. You too.
Good night, man. Okay. Bye bye from New York.
Bye.
Bye.